Recording in progress.
Okay, so we have these questions of the kinematics. P1. Bismillahirrahmanirrahim. The first question is about the graph. The graph relates to the motion of a falling body. Which is a correct description of the graph? What is y and what is on the on x-axis? They have mentioned time. What can be y?
Y can be.
Mhm. If you see, this is not a straight line graph, so
Yeah.
it must be. You cannot say that this is distance because in distance time graph, what you get?
Straight line.
Hmm. This is, and also what they're saying that there is the body is falling. The graph relates to the motion of a falling body, and this graph is leveling off over here. If you see, it is not the steep. So what can be the possible option for this?
It can be speed, and
Hmm.
air resistance is negligible.
No, if air resistance would be negligible, you know what now? What can be the graph? The graph will be like this. It will go this straight.
Mm.
You cannot say the air resistance is negligible. There is air resistance.
Okay.
So this is y can be speed and air resistance is not negligible.
Okay.
So the option can be y is speed and the air resistance. Yeah. Option can be D option. Okay. Why? Because what I'm saying you, the body is freely falling. Okay. So what does it
Yeah.
mean?
That means that the graph will be a curve.
Hmm. What you will get from speed time graph?
From speed time graph,
The gradient of
or the
speed time
gradient
graph.
is acceleration.
Yes.
Acceleration.
Yeah. The velocity time graph. Sorry,
Oh, yeah.
we get acceleration from velocity time graph, not from speed time graph.
Yeah.
Okay, and what
Yeah.
we get from the area of speed time graph?
The displacement.
No.
Distance in the
Yes,
speed time
distance,
graph.
distance. Because for if you have velocity time graph, then you will get displacement from the area of
Yeah.
velocity time graph. Okay. Question number two. Which graph represents the motion of a car that is traveling along a straight road with a uniformly increasing speed? Okay, they are saying the speed is increasing uniformly. So
The
if
speed is
the
increased for
yes,
it's
firstly you will
okay.
eliminate these two, the C and D, because in this they have mentioned the displacement. The
Yeah,
speed
that's
is not related to displacement, so you can eliminate these two options. Now you have A and B, and
uniform speed.
uniform speed. So it means
So A.
yes, A option. Because whenever you have uniform speed, it means the acceleration will be constant.
Yeah.
Okay,
Yeah.
acceleration will be constant. Okay, then a stone is thrown upward from the top of the cliff. After reaching its maximum height, it falls past the cliff top and into the sea. The graph shows how the vertical velocity v of the stone varies with time t. After being thrown upward, r and s are the magnitude of the areas of two triangles. Now what they're saying that there was a stone, it was thrown upward. So when it will be thrown upward, what will happen? Its velocity will decrease, right? Because it is moving against the gravity. Then in the start, and then they have taken it to the top. After reaching its maximum height, it fall past the cliff of into the sea. They are saying it is present on a
Okay,
top,
makes sense.
and you are throwing it into the sea. The graph shows how
Yeah.
the vertical velocity v of the stone varies with time. What is the height of the cliff top above the sea? What
So
can be the height? Hmm. If you see,
um,
you
the
know
height
what?
of
Firstly, you must
the
know this
cliff.
is velocity time graph, right? So what
Yeah.
you get from the area of velocity time graph? Because they have
The
mentioned the
displacement.
area. Yes. So we can get displacement from the area of velocity time graph. Now what can be the upward area? The R or
The
S?
upward area.
Hmm.
S.
No. They
No.
are saying that a stone is thrown upwards from top of a cliff. Initially, that was at the top, and from that they are throwing it. So your upward area will be R, and downward area will be S. Are you getting my point? What I'm saying? Read
So
this
upward
statement, the
area
first
will
one.
be.
They're saying a stone is thrown upward from the top of a cliff. It was not on the ground initially. It was on a top, and now they are throwing it upward. Like you are standing on on some height, and then you throw something upward.
Yeah.
So this is what they're saying. So when you throw it upward,
Okay.
the initially it will decelerate, right? So that's why
Yeah.
R will be your upward displacement. Are you
Oh,
getting my
okay.
point? The first point is
Yeah.
because it is decelerating first initially, and then when it will come back, if you let me draw this, wait a minute. Maybe this is the height on which this was present. Now you have thrown it on some height. Okay. In this, it is moving against the gravity. So at this point, it is decelerating. That's why R is your first upward area. Then it will start coming back towards the earth. Now it will start to accelerate. So the S will be second area.
Yeah.
Now you need to tell what is the height of the cliff above the sea.
Above the sea, it
Hmm.
will be R. R
Yes.
minus S.
Yes, exactly. You got this.
Yeah.
Okay. Now, a particle is moving in a straight line with uniform acceleration, which graph represents the motion of a particle. Uniform acceleration. Now they are talking about uniform acceleration. You will eliminate this, okay, because this is distance time graph,
Yeah.
and you will also eliminate this because uh, the area of acceleration time graph or gradient of acceleration time graph, you don't get acceleration from the acceleration time graph, okay? You get acceleration from velocity time graph, from the gradient of velocity time graph. Now you have two options, B and C. They are saying uniform
It's C.
acceleration.
It's C.
No.
No. But
Oh,
in
yes, it is
acceleration,
C. It
the.
is C. Yes, it is C. Because this is for constant.
Yeah.
The B is for constant. Okay. A projectile is launched at a point O, this, and follows the path O, P, Q, R, S as shown. Air resistance may be neglected. Which statement is true for the projectile when it is at the highest point Q of its path? Which statement can be correct?
Um.
We have discussed it at highest point, but what we say?
Yeah. But then
The vertical
the
velocity,
horizontal component isn't zero.
horizontal
It's
component
not
what?
zero.
Yeah, horizontal component is not zero
You
at
said
height.
it stays the same,
Your
but
vertical component will be zero. The vertical velocity will be zero,
yeah.
but your horizontal velocity will not be zero at this point.
Yeah.
And so the horizontal component of the projectile acceleration is zero. This is wrong. The horizontal component of the projectile velocity is zero. Sorry, this option A is correct because the horizontal component of the projectile acceleration is zero. They are saying acceleration is
Acceleration
zero.
is.
Hmm.
Yeah.
We have discussed it that the horizontal component of the acceleration is zero at the maximum height, right?
Yeah. Yeah.
So the option A is correct. Are you getting this, or are just you are just
Yeah.
saying
I'm
yeah, yeah,
getting. I'm getting.
yeah? Okay,
I get it.
okay, yeah. This is from the physics and math tutor. Okay, now read this and tell me what they are asking.
Two more.
Hmm. It's quite easy. It looks
Okay.
like difficult, but it is easy. It is from the equations of motion. You will use equation of motion over here.
To give the acceleration,
Mm-hmm.
um, to give the acceleration, you need to add, right? Add t1, t2.
Yes. You need to tell firstly, they are saying two markers M1 and M2 are set up a vertical distance h apart.
Yeah,
So this is the distance h from M1 and M2. These are two markers. When a steel ball is released from the rest from a point a distance x above M1. So the position of the steel ball is this. That is at x distance from M1. And it is found that ball takes time t1 to reach m1 and time t2 to reach m2. Okay, m1 to reach m1 it takes t1 and to reach m2 it takes t2. Which expression gives the
yeah.
acceleration of the ball?
It
Hmm.
it's B, I think,
How?
because you have to add the time you get from t1 and then time you get from t2.
No, it's not the B. Firstly, initially you
It's
need
not.
to solve it because the acceleration. Firstly, when you will release from m1, like the ball is at this position now, and you
Yeah,
are releasing it from this. So the equation you will use is the S equals half AT square. You know this equation,
yeah,
right?
yeah.
Then
Mm-hmm.
you are releasing it from if you release that ball from the M2. Now at M2, what you need to do? You will add H. Like at this position, it will be S plus H, right? Because this
Yeah,
is H. S plus H, and it will equal to half AT square. Okay, this is at M1, this is um, T1 and this is T2, right? Are you getting this, what I have written? Okay, I'm saying at this
your voice
point,
is distorted. Can you
I'm
say it again?
saying at this M1, your S will be half A T square, T1 square, right? Because this is T1. Are you clear with this? Mhm.
Yeah, yeah, I'm clear with that one.
Okay. Now at this point, your S will be what? You will add this H.
Wait, what? I can't
S,
hear you.
no, why it's happening? Wait a
Is it
minute.
your Wi-Fi?
No, there's no issue with my Wi-Fi. I don't know what's happening. Is there any distortion in my voice? Or is it glitching?
It's distorted.
Okay.
It's a little distorted.
It's My connection is good. I don't know what's happening. Can you hear me now, or it's still the same?
Yeah, I can hear you now.
Okay. So this is now at this M2, your distance will be S plus H because you have H height as well. Okay. S plus H half AT T2 square. Now you have two equations. What you need to do to get H, because you have to use H, right? You want H. What you need to do? You will add these two or you will subtract, because you need to know
We
the
will
acceleration. You need to know the
subtract it.
acceleration. Sorry,
Yeah. Can you repeat that? Like, I didn't get the last part.
I'm saying now you have two equations and you need to know the acceleration. So what you will do? You will add these two or you will subtract these two.
You subtract these two.
Yes, exactly. We will subtract, and when we will subtract, what will we get? We will get, if you have this equation S over here, this is equation 1 and this is equation 2, let's say. So it will be, you will get the final equation S minus, and then that will be Firstly, s plus h equals half at 2 square. And then you have this equation that is s equal half at 1 square. If you subtract this, this h will be cancelled, right? When you subtract it. So basically you will get h half a t 2 square minus t 1 square. Are you clear with this, what I have done?
Yeah.
Okay, and then what can be the final expression for a? You can take this to over this side. This will become 2h equals a t2 square minus t1 square, and this will be in denominator now, 2h over t2 square minus t1 square equals a. Clear?
Oh, yeah.
So
Okay.
your final expression will be
D.
yes. So don't just rush. And we say there is an idiom in English, hold your horses tightly until you
Yeah.
understand the question and then solve it. Okay. Uh, then there is a question. A ball, a body falls from the rest in a vacuum near the Earth's surface. The variation with time t of its speed v is shown below. Which graph shows the variation with time t of the speed v of the same ball falling in air at the same place on the Earth? Now they're saying you have a body that fall from the rest. Okay, it was initially on the rest in a vacuum near the Earth's surface. The variation of time and speed they have shown you. Which graph shows the variation with time of the speed of the same ball falling in air? Now it is in the air at the same place on the Earth. Initially it was in vacuum at rest. Now they have taken that
So
ball
there's
into
air.
the air. Yes, that body into the air.
Okay, so there's air resistance,
Yes,
which
there
would
will be
be
a resistance.
B, I think.
B,
B. B or
you
either
must.
I feel like it will be
Uh-huh,
A, I think. A.
no.
No?
Mhm. You don't have a in a you sure you have this constant value. How can be this? There is
Hmm.
uniformity. This is showing uniformity. It's not the case.
Can you spell?
Hmm.
Mm, it can't be C.
Yeah, it can't be C. These two are eliminated. It can be B or it can be D. In which graph the steepness is increasing, the gradient?
B.
B. But we are saying we are talking about the speed, so we will not take into consideration the speed, right? Like we don't have,
We're talking
we
about
are not talking
gradient?
about the velocity. We are not talking about velocity. We are talking about the speed. So you must see in
Speed.
these two graphs, in B and D, in which graph speed is increasing. Because when you take body from air from vacuum into the air, the speed will increase initially, right?
Yeah.
And then it will become constant after some time. Because you see, this is constant. So you cannot say that initial speed will be constant. Initially, the speed
Initial.
will increase when you will take that body from vacuum into the air. The initial speed will increase. Now tell me which graph can it be, in which the initial speed is increasing and then it is decreasing.
It's increasing in both.
Yes, but you see, there is a difference of steepness.
Yeah.
This one and this one.
At D, they get constant. B is D is steeper.
Yeah, so D is the option. This is the correct answer because in air, speed increases and then afterwards it will become constant. This is actually a concept of terminal velocity as well. You can remember this. We will
Yeah.
discuss terminal velocity in the upcoming videos. But at this stage, you must know that we are discussing that in when you take any body from the vacuum into the air, the speed increases, and afterward it will become constant because this is constant. This graph is showing a constant speed. That's why it will become constant. Clear?
Okay.
Okay.
Yeah.
Then which of the following is a scalar quantity? It's very simple question.
Which of the following is a scalar quantity?
Hmm.
It's mass.
It's mass. Okay. Yes. Okay. Wait a minute. ये एक मिनट बात सुने. ये बटन ऑन कर दें चार्जर का. हाँ जी हो गया. जज़ाकल्लाह. Okay, a projectile is fired at an angle alpha to the horizontal at a speed u as shown. What will be the vertical and horizontal component of its velocity after a time t? Assume that air resistance is negligible, the acceleration of free fall is d. Now they are saying a projectile is fired and they are asking for the vertical and horizontal component of its velocity after time t.
After time t.
Mhm. You know
Vertical
the horizontal component is simple. Horizontal
component
component will be
will be
u cos alpha. Horizontal component will be u
cos
cos alpha,
t.
right? But for vertical component, they are saying
Actually,
assume that
why is it
air resistance is negligible. The acceleration is free fall, right?
okay? Yeah.
So what can be the possible answer?
So
Uh-huh.
I think it will be C,
Yes. Why?
because you remove the thing, but in the horizontal component it will remain the same, but
Yes.
in a vertical component you remove air resistance.
Yeah. You remove, there is no air resistance, so you will subtract the gravitational acceleration and time from it.
Yeah,
Okay. And if they say that air resistance is not negligible, then what equation you will use?
it's not negligible, so you will use A. It'll be A.
Yes, it will be A in that case. Okay, now. The graph of the velocity against time for an object moving in a straight line is shown. This is velocity time graph. Which of the following is correct? Is the corresponding graph of the displacement against time. Now you need to tell the displacement time graph for this.
The graph of velocity against
Sorry.
straight line. I'm just reading it. For displacement, it will be
Hmm.
increasing and
Firstly,
then
velocity. Yeah, you
I think
need.
it will be
Uh-huh.
like. Can you zoom in a little bit? At first, it's increasing.
Yes.
I think it might be A.
No, it is not A. Is this? How
It's
can
not.
this be A? You know this. What is this? This is not a straight. This is like.
It's not straight,
Yeah. You cannot take this.
but showing the
And
decrease.
yes. Firstly, you need to know about this. What is happening over here? The velocity is increasing, right? So it means
Yeah.
displacement will be increasing. So displacement will be increasing. This is wrong.
Okay. Yeah.
And afterwards, if you see, this is constant now. It is it become constant velocity time graph. So it means your displacement time graph will become uniform, right? It will become
Yeah.
like this.
Uniform. Constant.
Okay. Then afterwards, if you see, the velocity is decreasing, right? So it means,
Yeah.
but even though it is decreasing, but you know, this is on the positive side. We
It's
have
not.
discussed it.
Yeah.
Yeah, it is not negative. That's why your displacement time graph will be like this. Clear?
Yeah.
So it will be C option. It can't be D. Why it can't be D?
Because it's too like steep.
Yeah, yes. There is no they have not shown any, you can say, what can we say about this? This is yeah, this is not steep, you can say. This is steep, but in this, you know, at different instant
It's
the velocity
constant
is
everywhere.
hmm. There is variation in
This
this
one,
graph.
that one,
Huh?
yeah.
What you are saying?
Oh, nothing.
Okay. Are you clear with this?
Yeah.
Okay. Then you have this 11. A ball is released from the rest above the horizontal surface. Initially, it was at rest. Okay. And above a horizontal surface, the graph shows the variation with time of its velocity. Now you have velocity time graph, and this is the first impact, second, and third. Firstly, over here the ball was falling, so the velocity was like this, and after that ball is rising, so your velocity will be like this. Then over here it started falling again and rising and falling. This is the graph. Area x and y are equal. This is because now they are asking in this, if you see, the area x and y are equal. Okay, they are saying the ball is released from the rest above a horizontal surface. And this is the graph. Now they are asking why area x and y are equal.
Y area x and y are equal.
Mhm.
Because because the acceleration is like
Because
when
you
it hits
know,
the
hmm,
ground, it goes in the opposite direction,
hmm,
but with the
yes,
same force.
yes, exactly. When you bounce it, like it when it will strike the ground, it will bounce back at the same height. Okay, this can be the
Yeah.
reason for the equal area. And it will happen when you have negligible air resistance. When resistance is zero, at that time they will be both on the same position. It will bounce back at same height. So this can be the option.
Okay.
Okay, we can check the ball's acceleration is
Wow.
same during its upward and downward motion. Is this correct?
The acceleration?
Is same during its upward and downward motion. It
Yeah,
is
but it's
not.
in opposite direction.
Yeah, it is not correct. Then the speed at which the ball leaves the surface after an impact is equal to the speed at which it returns to the surface for the next impact. This is also wrong because speed
Yeah.
cannot be same.
It can't be
For
same.
hmm, for one impact, the speed at which the ball hits the surface equals the speed at which it leaves the surface. For one impact, the speed at which the ball hits the surface equals the speed at which it leaves the surface. No, because you know when I gave you the lecture, I told you that there will be a slight difference in the speed. The speed cannot be same. They're saying for one impact, the speed at which the ball hits the surface equal to the speed at which it leaves the surface. How can these be equal? These two speeds
Mm,
cannot be equal. And the ball rises and falls through the same distance between the impacts. This is the reason. This is what I am saying, that they will bounce back at the same height. This can be the reason when you have equal area. In the second impact, they are at the same height.
yeah.
Okay, because equal area means equal displacement. Because you are taking the velocity time graph. So the area of velocity time graph gives you displacement. Whenever you have a question like this, you need firstly check the area and the gradient, what you are getting and what they are asking for it. They are asking about the area. They are asking about the area. So you know the area of velocity time graph gives us displacement. Then you can think about how we can relate displacement in this question. So that's why you don't need to check the speed, you just need to check the distance because displacement is a vector quantity and that you know when it will bounce back, obviously we will get displacement in that case. Are you clear?
Yeah.
Okay. A motorist traveling at 10 meter per second can bring his car to rest in a distance of 10 meter. If he had been traveling at 30 meter per second, in what distance could he bring the car to rest using the same braking force? Okay, now you must solve it because it is very easy question. You were asking me how we will use equations of motions. Now this is a question. You have two values of velocities and they have given you the distance. And you have to find in what distance could bring the car to rest
Mm,
using the same braking force.
you have to use the. They didn't give time, so you have to use the third formula,
Okay, what's that?
right?
Third equation of motion.
Third equation of motion.
What's
It's
that?
v squared plus u
Hmm.
squared.
V
equals
square
2as
plus U square.
minus v square
Hmm.
minus u square equals 2as.
2as equal V square minus U square. Okay. This. Now, what
We
you
have
need
to
to do?
find what? Which one? The distance.
Hmm. You need to find S.
Distance. Find as.
Hmm.
They didn't give since
Hmm.
can we use 9.81 as the acceleration?
You can cancel this factor because you have two values. You know, simply what you can do is a motor is traveling at 10 meter per second, bring his car to the rest in distance of 10 meter. Now they have given you this distance, 10 meter.
So first you use that formula to find the
Hmm.
acceleration.
Yes, but how, in this case, what can we do? Because, they are saying that the braking force is same braking force. Okay. Whenever you have question like this, you can mold this equation. How can you use this equation? Simply, you can take this factor that when there are same braking forces, so the distance will be dependent on your initial velocity. Like for example, you can use this equation. Wait a minute. S equals there is U and there is S2 over S1. Basically, you will have S2 for this S1 and U2 over U1. U2 means the V, final velocity. Are you getting this? What I have written? You can directly use it, or you can eliminate this acceleration factor because acceleration will be same.
Which formula is this?
I
Which
have
equation is
just
this?
just used this equation. I have what I have done is, the distance will be directly proportional to this. Okay,
Yeah.
distance will be directly proportional to U square, initial velocity or final velocity. So I have taken this equation. S2 over S1 will be equal to U2 over U1. And U2 is what? Final velocity. You can directly use this. I am telling you this. When they have given you three values. Now you just need to know the fourth one. What you will do, if you know S2, you have to calculate S2. What is S1?
S1 is S1
Mm-hmm.
is 10.
Yes, S1 is 10. And U2 is what? That is 30. 30 over 10, right? 30 square. You have 30 square over 10 square into 10. What you will get from this equation? Are you getting this what I am doing? Or you can, okay, just forget this. Do this by the equation which we are using over here and tell me the answer, what you are getting. This equation.
Okay, I'll say.
Okay.